Coroutines. Coroutines in Unity are sort of like functions, except they give you the ability to yield the program, which basically just means to stop it from running for a certain amount of time that you might want it to. On the screen is a pretty basic example of a coroutine. In this one, I use a coroutine for the start function as well, so I have the ability to yield during that. I print the starting time, then I yield until wait and print is finished, and then I print the time as it's finished. And then wait and print is a different coroutine that will wait for the seconds that is input as its parameter, and then print out when it's finished. In play, it looks something like this. A more complicated example of a coroutine would be this. In this example of a coroutine, the coroutine will continue looping until it hits a certain number, and it will continue to print things over intervals of time. When it hits the correct number, it will stop and print out tests completed. Coroutines are great if you ever need to manipulate time in Unity or do things on a timed basis. Delegates. Delegates in Unity are essentially variables that hold functions. The benefit of using delegates is you can assign different functions that use the same type of parameter and change them at your will. In this example, which is pretty simple, you can choose to print the number or to double the number, both functions using only an integer parameter. And the delegate doesn't have to change. All you have to do is set which function the delegate represents. Delegates also have the advantage of being able to be multicasted. What this means is you can assign multiple functions to the delegate at the same time. In this example, I have a delegate called spawnShapes. SpawnShapes takes an integer parameter, as well as the spawnCube, spawnSphere, and spawnCylinder functions. What this allows me to do is add or subtract any of those functions at any given time to use them when I want to. So as you can see, I add spawnCubes, I add spawnSphere, and I add spawnCylinder, and then I run spawnShapes. This will run all of those functions. Then I subtract spawnSphere and subtract spawnCylinder and run it again, meaning that it's only going to spawnCube. This could be useful in something like a tower defense game, or other types of games where you might need to switch out different types of functions. Lambda expressions. Lambda expressions are like functions, but can be declared in line. In this example, the showMessage lambda expression takes two arguments, a string and an integer, and then will print the string the integer amount of times. Generics. Generics in C# is essentially a type that you haven't declared. And this can be useful because you can create an object that can take multiple types depending on what you want it to do. For example, in this example, I have created a class called container, and container has a single value of the generic type. What this means is I can create an integer version of this container object, or a string version of this container object, or any other type of this container object. And so in this example, I create a health container that is an integer, and a name container that is a string. And then I set their values and display them. Multithreading. Multithreading in Unity is essentially going to allow you to use multiple threads instead of just a single thread, meaning that your code can run simultaneously on the CPU. In this example, I create two separate threads, T1 and T2, and then run them both at the same time. Then I wait for them to finish, and run the third function on the main thread. When you see the output, you'll see that A and B are intermixed together because they were running adjacent, whereas C is going to be by itself.